Okay, let's take a look at roof structure materials, the things that hold the roof up and the structure of the roof and how it works. So let's take a look here. And we know that um, we're going to rely on lumber design values again, just like we did with walls and just like we did with joists for a floor and things like that. Now we have things called span tables. They're published in building codes and standards, and a bunch of the industries have their own technical publications. So when we look at the design values, we need to know the loads, how much force is being applied, or pounds per square inch, or pounds per square foot. What's the load? What's the span? Just like we had before with floor joists, we need to know the span, how far across it is between supports, and the spacing. How often are the joists and the rafters or the trusses spaced? So those are the design values that kind of drive our choices. So our tables that we've got, and it's a lot like our engineered joist and trusses that we've already used. Um, they've got the type that's like select or stud or number one. There's a species and a grade, and actually the species and the grade comes first. Doug fir larch is very common here. There's the load, and now we got to talk about dead load, live load again, but they get a little bit more specific about it. And then, of course, we have our lumber size 2 by 4, 2 by 6, 2 by 8, etc., and the spacing, how far apart the joists or the rafters are spaced. And that's often, 12-inch, 16-inch, 24-inch, things like that. So now we have a very complete set of charts, and you read the charts to find the maximum span allowed. And then, of course, you can compare that to your design. And if your design has a span that's bigger than the maximum, you have to do something to change it. If you have something that's a, a lower than but near the maximum span, then you're pretty much right on. And if your span is way short, compared to the maximum allowed, you might be using too much material, might be costing a little too much, so you can look at that. So this maximum span allowed is really used in your review of your design. Sometimes um, you need to determine design values to meet a need, and we'll show you about that. And then sometimes you're checking your rafter design again just to make sure that you're okay. So those are the three ways that you use the charts. So let's look at it really quick. First, there's load, span, and spacing, and we want to remember that load, there are dead loads. Those are the constant permanent forces acting on the roof. It's the weight of the roof material, the weight of the trusses, the rafters, the sheathing, all of those things that are permanent. Other permanent ones could be if you've put a, a heating or an air conditioning unit up there, or solar panels up there, or something like that that has a fixed weight. Those would be dead loads. And live loads are temporary or available. There's live loads right there. Snow, in our area right here, not so much, but as soon as you get a little bit up the hills, snow becomes a factor. Rain is a factor. Wind, we said before that wind and rain combined make a lot of load, and wind for roofs tends to lift the roof. On walls, it just sort of tried to push it over. But for a roof, because of aerodynamics, you can actually get lift just like a wing. And then you've got just the weight of maintenance workers walking around and things like that. So you've got dead loads and you've got live loads. The next thing to consider is the span, and that's the distance between the supports. Okay, so here's from here to here is one span. From this bearing wall to the exterior spacing is another span for the joists, but the rafter span might be different. That's from here to here. Okay, and different rafters have different designs and they might have some slightly different calculations of span. But basically, it's the distance between supports. And for spacing, it's how far in between the rafters or the joists. They're not always on the same center. Sometimes you have more joists than rafters because you have to hammer nails into it or screws or something to help hold up a ceiling. So rafter spacing and joist spacing are not necessarily the same, but the distance between them, center to center or edge to edge, is called the spacing. So those are the three things that we sort of have to work with and think about. So next is, how are the tables organized? Well, first, now the tables are by application. There's tables for floor joists, for ceiling joists, for roof rafters, and there's even more on there. And then each of those has a live load, dead load component. Live load, dead load, and an L360 or L240. Um, and remember, that's how much sag you're going to allow. Okay, and so you sort of have to know for your design what applies. What is your application? What are you using it for? And sort of what load situation are you going to fall under? Now, many designers have experience and they just know that because they've worked the codes. But when you're just starting out, your architect is going to be, well, the architect is responsible anyway. But your architect will probably point you to which table to use. Once you have the application, you go to your span table, excuse me, and you look up your species and grade. Species and grade. And as we said, Doug fir larch is really, really common around here. And, you know, for framing and things like that, often you're going to call select structural for most of this, but you could use number one and better if the numbers work out for you. And once you've found your application, looked at your design criteria, which are your loads and your deflection, and then gone to find your species and grade, then you go to the size and spacing. And remember, first you look for your lumber size. What size have you chosen? 2x4, 2x6, 2x8, so on and so forth. And then what spacing have you chosen in your design? And then you can look up your max span. And the way you would read this one right here is 9 foot 1 inch. So in our quiz, you're going to be actually asked to say 9 foot, which is the apostrophe, dash 1 inch, which are the quote marks. No spaces in all of it. So you're not going to write it like this. I want you to understand. I want to make sure that you understand that that's a physical measurement of length, 9 foot 1 inch. This one would be 8 foot 3 inches, 7 foot 9 inch. Okay, so that's how we organize and read these tables. And then finally, we get into using the chart. So what do? Let's read the chart. identify your application. That's your rafters, joists, whatever, and your load. 60-pound snow load, 10-pound dead load, L over 240 as an example. Okay, then we look at our joist material. Here we see a Doug fir larch and a select structural. So that's step number 2. Step number 3, pick a desired joist size and spacing. So if I've got 2x8s on 16 on center, because that works for me, then I can find the span limitation. And so this would be a largest of 13 feet 7 inch. I know that's hard to see on this little screen, but that's what it is, 13 feet 7 inch. So now that's how you would read it if I want to check a design. If a designer has told me they've got 2x8, Doug fir larch, 16 on center, 60-10, and the largest span in the design is 20 feet, we're going to go in and check roof rafters, snow load, dead load, species. I've checked all of this, and I come out that a 2x8, 16 on center, is 13 feet 7 inch maximum. Well, I'm trying to go with something bigger, 20 feet. So this design will not work. Okay, so now maybe I say, well, I want to keep my 20-foot span. What do I do? So I'll go choose some different design values. So if I look at maybe I want to stay with select Doug fir, I want to stay with 16 on center, 60 and 10, and I want to keep my 20, what can I do? I can increase the size of my timber, and I can keep checking, checking, checking until I get to one that's over 20 feet. So I find that a 2x12 looks like it'll do it. Here it is, 2x8, no good. 2x10, no good. 2x12, my 16 inch comes out at 21 foot 1 inch, and that works because it's bigger than the 20. So that's using the charts. And that's all there is to it. If you get used to reading these charts and looking at them and seeing how they work, you're going to be a nice step ahead in the industry as you get moving.